Hi, in this video we're going to look at one last example of how to find an unknown force when an object is accelerating. Sorry about the bad audio quality on this one. My microphone died in the middle of me recording this video the first time, so I'm recording it again here. So let's look at an example. It says, Pancake, the cat, stares longingly at a juicy 2.5 kilogram squirrel as it jumps from a tree towards the ground. Being an expert in physics, Pancake notices the squirrel accelerates at 7.50 meters per second at one point in its descent. How much air resistance does the squirrel encounter at this moment? So I've drawn my picture here. We're going to draw a free body diagram. Keep in mind we are focusing just on the squirrel, right? So we're drawing forces that are acting on the squirrel. So that would be the force of gravity pulling the squirrel towards the earth. There is also some air resistance. We don't have any horizontal forces, so the horizontal net force would just be 0. The vertical net force is going to be the two forces added together. So that's gravity plus air resistance. So we're given some information about the squirrel. We have the kilograms up here, which tells us the mass of the squirrel is 2.5 kilograms. It says it jumps from the tree toward the ground, and Pancake notices the squirrel accelerates. Okay, so we have an acceleration of 7.50 meters per second. Acceleration is a vector, so we have to include direction. And the squirrel is accelerating downwards. It's moving down and it's speeding up. And so we have an acceleration that is downwards. So we need to include a negative sign there. That's an easy thing to forget about. But remember to include direction anytime you have a vector. Finally, we are looking for the air resistance. So that is our unknown. So how much air resistance is there? For our equation, we're going to use Newton's second law. The net force equals mass times acceleration. I'm going to rewrite this equation, though, with the net force in this particular example, and that is what we've written down here. So the net force is the force of gravity plus the air resistance. And that is equal to the mass times acceleration of the squirrel. All right, so we need to know the weight of the squirrel, right? That's one of the quantities we need to know, and hopefully you remember by this point that you can always find the weight of an object by multiplying mass times g. The mass is 2.5 kilograms. G is negative 9.81 meters per second squared. So the mass of the squirrel is 2.5 times 9.81, about negative 25 newtons. So now I have all of my info that I need. I have the weight, I have the mass, and I have the acceleration, and I'm going to solve for the air resistance. So I can substitute in my weight, which is 25 newtons, in the negative direction. The air resistance is the unknown, and the mass is 2.5 kilograms. The acceleration of the squirrel is negative 7.50 meters per second squared. All right, so I'm ready to multiply 2.5 times 7.50. So 2.5 times 7.50 is 18.6. I'm going to round that to 19 because I need two significant figures here. So that's equal to, we have negative 25 newtons plus the air resistance. So now we're ready to add this 25 newtons to both sides. Okay, and that cancels it out over there. And our air resistance is positive 6 newtons. It's positive because the air resistance is up while the gravity is down. So An air resistance of 6 newtons does make sense because the weight is 25 newtons, so the weight should be bigger than the air resistance. So that's all I've got for you in this video. Remember, confusion is the sweat of learning.